Welcome back to our C# tutorial. Today we are diving into a powerful feature, asynchronous stream. This addition to C#8 is gonna enable us to efficiently work with asynchronous data flow, making it easier to consume and process data stream without blocking the main thread. Let's explore first what exactly are asynchronous stream. That one is gonna allow you to work with sequence of data that are produced asynchronously. Before C#8, handling such a scenario required a workaround like buffering. But right now with asynchronous stream, you can now iterate through asynchronous data using the await for each loop. Or use the async enum interface to represent asynchronous sequence. So we can say asynchronous stream is a way to represent and consume a sequence of data that are produced asynchronously. Think of it like, imagine you are waiting for multi-items to arrive in a queue. And instead of waiting for the entire queue to fill it up, you can start processing item one at a time as they arrive. Which is gonna take us why we're gonna use this asynchronous stream. Actually for three reasons. The first gonna be improve efficiency because process item as they become available, reducing memory usage. So no need to buffer large data set in memory. Second, non-blocking execution. The await keyword ensures that the main thread isn't blocked while waiting for the next item in the stream. And last, simplified code. Eliminate complex threading logic. And now, let's go to next question, how asynchronous stream work. Let's break it down into two parts. The first, the producer itself, which is gonna generate data asynchronous using the yield return statement and wait. Then implement asynchronous enum interface. This is the first part. On the other side, the consumer, he gonna consume the data stream using the await for each loop, which gonna process each item as it become available. So let's switch to Visual Studio and see a real example here. Before I gonna explain anything, I will go and execute this one. As you can see, the producer generate number async, which is gonna create a number with a delay. And the consumer, he gonna process each number as it's received. So what's happened here over there? First, we have here a method, which we call it generate number async. This one gonna create number with some delay. Here is it. We have task.delay. As you can see, we are producing number with some delay. And on the other side, here we are using await for each to process each number as it's received from this method and then printed here on the screen. So we can consider the first part here as a producer, which represented by this method. But hey Darwish, I can see here async enum int. Yes, this one we're gonna say it's like integer asynchronous, which is gonna be a data type. Okay, and inside this method you can find here a for loop. That one gonna iterate about the number starting from 1 till 5. And using this task.delay 1000, which is gonna simulate a delay of 1 second before producing each number. Okay, so where data take time to arrive from your producer to your consumer. And here we are using yield return. That one gonna produce one number at a time for the consumer. On the other hand, we have here the consumer. That one have, we can say, very important one, await for each. Yes, that one you can say it's a process number as they become available, as we discussed. But let's think here each number is awaited individually, like ensuring the main thread is not blocked while waiting for the next number. So I can say that use case is ideal for scenario where data is generated or fetched over time, such as streaming a video frame or reading log incrementally. The output here, as you can see, every second a new number is produced and displayed. This process is non-blocking, meaning that the program doesn't wait for all numbers to be generated before processing them. Next, we can use this feature to simulate sensor data, like temperature, for example, which is very perfect for IoT applications, Internet of Things, where devices like temperature or pressure sensor continuously stream data in real time. For example, every 500 milliseconds, a new temperature reading and generated and displayed. So let's have an example. And that example gonna again have the same way of producer and the consumer, but this time gonna simulate sensor delay for the random temperature, which gonna generate between 20 and 30 temperature reading. If we're gonna execute this application first, and here you can find temperature every delay, which is like half a second, as you can see from delay 500, one time 28, 26, 24, and keep going like 10 times. And let me have a look again. Here, starting from the random temperature, we can say we're gonna simulate a real world scenario, okay, where IoT device gonna generate for you temperature, gonna read from 20 up to 30. So first we use the task.delay to simulate sensor delay like half second, and again inside this method simulate sensor data async, we have a data type of async enum, but this time of type integer. Again we are using yield return, which is basically send one temperature reading to the consumer at a time between 20 and 30. On the other side, the consumer, he's using await, and this one await for each. It's basically to read the temperature data. It's like each temperature reading is awaited and processed immediately. No need at all to wait. Okay, that's why inside the console we're gonna display the temperature as soon as it's received from the producer. So we can say in this session we explored the powerful of asynchronous stream in C#8. This feature transforms how we handle data flow, making our code cleaner, more efficient, and scalable for the real world. And throughout this video cover two examples. The first one, generate and consume asynchronous data stream using async enum, and then we're gonna use the T, which is basically for the data type, and that one, it's basically an interface. Even we used wait for each on the other side. The next example that we discussed as well, it was simulate real data scenario like sensor data used by temperature. So here we're gonna say asynchronous stream open up a new possibility for developer to work on modern application, especially in domain like IoT, Internet of Things, and API. Definitely it's very important in API and real-time data processing. In our next session we will dive more into pattern matching enhancement. Cannot wait to see you there.